Welcome to the DIVI Group sharing channel. Today, we introduce a project designed and installed by DIVI Group in 2024, an 8 million kcal per hour thermal oil boiler at a plywood manufacturing plant in northern Vietnam. This is the second thermal oil boiler that the customer has entrusted to DIVI Group. The system was designed with fluidized bed combustion technology and a vertically coiled tube structure. To extend combustion time and improve fuel efficiency, the DIVI Group team optimized the height design, aiming for fuel savings while ensuring environmental compliance. In 2020, the customer entrusted DIVI with designing, manufacturing, and installing a 5 million kcal per hour thermal oil boiler system to replace an outdated manually fired wood boiler. Thanks to the customer's satisfaction with the previous project, in 2024, they once again chose DIVI to design a new 8 million kcal per hour thermal oil boiler system. This system uses fuel derived from forestry byproducts, including sawdust, wood chips, offcuts, domino blocks, bark, and veneer scraps. The fluidized bed combustion technology allows the use of mixed fuels without the need for sorting, reducing operational costs. The new thermal oil boiler system has significantly lowered fuel costs for the customer. Based on actual operations, the old system required up to 12 buckets of fuel per hour, whereas the new DIVI system requires only 8 buckets to meet production demands. The thermal oil boiler is equipped with an automatic conveyor system that transports fuel from the storage hopper to the intermediate feed hopper. Combined with a fuel feeding fan, this system ensures even fuel distribution across the grate surface, optimizing combustion and improving fuel efficiency. The fuel burns in the combustion chamber, which has a height of up to 11 meters, allowing for more complete combustion. Through radiation and convection heat transfer, the oil inside the pipelines is heated to the required temperature without exceeding 300 degrees Celsius. To meet the factory's current needs, the heat transfer oil reaches 248 degrees Celsius before being circulated to heat-consuming equipment. After transferring heat, the oil temperature drops to 238 degrees Celsius before recirculating back to the furnace, forming a continuous heating cycle. This is the fuel feeding system for the thermal oil boiler, including the conveyor and feed hopper. Next is the combustion process within the furnace. The flue gas generated after heating the oil is directed to the heat recovery unit. In the air preheater, the airflow is heated to nearly 200 degrees Celsius before being introduced into the combustion zone, improving fuel combustion efficiency. This is also where the primary air supply fan for combustion is located. The flue gas then passes through a cyclone dust filter, capturing over 85% of the ash particles. Below the cyclone, an ash hopper and rotary valve collect and discharge the ash. Next is the induced draft fan, which enables the flue gas to move from the combustion chamber through the air preheater, cyclone dust filter, and chimney. The exhaust gas temperature is maintained below 160 degrees Celsius, indicating the high efficiency of the DIVI-designed thermal oil boiler system. Before being released, the flue gas passes through a water-based scrubber system that captures fine dust, ensuring environmental compliance. Here is the emissions monitoring device used by regulatory authorities, with all measured values significantly below the permitted limits. When the system operates, and the exhaust appears as light white steam, all emission parameters meet environmental standards. Finally, let's take a look at the control panel system. As usual, the control panel is housed in an aluminum glass room and cooled by air conditioning. The entire system operates via PLC, with parameters displayed and adjustable on a touchscreen, ensuring easy monitoring and control. This concludes our brief introduction to the 8 million kcal per hour fluidized bed thermal oil boiler system by DIVI Group. Utilizing forestry byproducts as fuel. This product not only helps reduce costs but also contributes to environmental protection by lowering greenhouse gas emissions and aligning with Vietnam's goal of carbon neutrality by 2050. Thank you for watching.